Well, good afternoon again. I'm wearing my presenter's hat this time, not the ONSEC. There's going to be a bit of a surprise in a few minutes. I've had a box handed to me. FUNcube and what's happening next. David's already alluded to one project, so I'm going to talk about another one. For those of you who don't know about FUNcube 1, launched in 2013, 11 years ago, and still operational. You can see how big she is, 10 centimeter cube, 1U and a 3U launcher with a spring at the bottom to push it out. Our friend Wouter actually working on it in its assembly all those years ago. We've got lots and lots of videos on YouTube about this, with the antennas springing out, etc. Thanks to Mr. Heck many years ago. Oops. Hang on. Current statistics. She's been in orbit 11 years. Raw packets transmitted in that time, just short of 69 million packets of data. We've received just short of 12 million of those, which is about 17%. The packets are transmitted at about every 5 seconds. That's where the maths come from. 24 of those packets actually make up the whole orbit data. The whole orbit data is basically the heartbeat of the system. The battery, the charge, the spin rate, etc. Over that time, we've had an awful lot of people presenting data to us in the warehouse. The maximum for FUNcube 1 itself is about 1,400 people. That's not the whole number, because we've also had Naive 1 and JY1SAT, and they've contributed to the warehouse as well. I say 1,400. Amateur radio operators are competitive. I'll show you a slide in a couple of seconds in terms of how competitive they've been. But for each of those packets we've probably actually received more than one instance of that packet. Current number is about 36, so it's dropped quite considerably. I'll explain about that in a second. But we are still getting real data and really useful data. The FUNcube family. Oscar AO 73 was FUNcube 1, of course. Launched about the same time as UCube 1, a UK Space Agency satellite with Clyde Space. We also were involved with another set of projects for ESA education, which is where EO 79 came in. Part of an interesting fact that's with FUNcube 1, because we're not for profit organisation, IC Space were approached twice for designs for CubeSats. Have you got anything off the shelf? Well, no, we haven't, but we know somebody who might have. So we licensed the design of FUNcube 1 as EO88 and JO97. I'll tell you a little bit more about that in the next set of slides. SAO, the European Student Earth Orbiter, is another project that we were involved with, and some of our payloads went into that in the same way that David's explained that FUNcube Lite is carrying other payloads. Reliability, we've been quite good. Everything fails, of course, eventually. AO73 is still alive and well. We're having some problems with the EPS, so we're actually having to actively manage FUNcube 1. UCube 1, it's the UK Space Agency in Clyde Space, lasted just short of 4 years. It's had battery failure. EO79 from the von Karman Institute, end of mission, negative power budget was one of the side effects we had from it. EO88, Naive 1, is still going and it's active after nearly 6 years. G097, JY1 sat, microcontroller failed, probably through radiation damage. And SAO, multiple design issues on the platform is all I will say. It was a student mission, lots and lots of things that could have been designed a little better right from the outset. But we got it up there, and it had a short lifetime. Again, as a repetition of that slide, we have flight history with all those satellites for 22 years. So I think AMSAT-UK and the FUNcube team can be extremely proud of that. David and Wouter and Duncan and Jason and Phil and others have been involved with all the boards we've actually built on the FUNcube system. Some of them, as David pointed out, are actually being reused and rejigged into FUNcube Lite. Extremely reliable. Most of our stuff has actually worked extremely well. We've had problems with some of the commercial off-the-shelf stuff, which we believe the EPS is one of them within FUNcube, but it's still going. It's still providing power. We still run the data warehouse, as I've said, with just 36 uploaders. We have some extremely regular ones, and N7RED in the audience here, I believe. There he is, waving away at me. Thank you, Andre, for that. The interesting number, if I can get it, is that one is the battery voltage. It's sitting max at about 7.9 volts. And we can get the min and max data over a few days. It's been up at about 8.4 volts, I think was the maximum we've ever had. It dropped down to about 7.2 before we started actively managing it. And it's quite happily sat at just below 8 volts. We've had to make some compromises because of that. Next slide, I think they show it. But you can also see we've got a significant number of packets. We did have something that caught us out because we've got every packet has got a serial number against it, and we rolled over the number of units. We rolled over the bits. So the warehouse got confused for a few days until we scratched our heads and worked out why the sequence number reset. So we had to do some trickery with the warehouse to actually catch up again. So what had been the original epoch in 2013 to actually make all the numbers work, we had to reset the epoch to a couple of years ago. But we've still got all the data, we've still got all the real time, we've still got all the WAD. But if anybody wants to do a PhD to recover it, we'll have to do some trickery to actually get the satellite time out. Mentioning satellite time, the onboard clock is just a crystal. And of course, it's drifted over time. And I think we're probably about 10 days out from what the real time is. But the average, we can actually do all the math with it. What else we got? We're still getting good whole orbit data. And the whole orbit data is the 95 minutes from an equatorial pass to the next equatorial pass. From that, you can see when we're in sunlight, when we go into eclipse, and then we come back out of sunlight again. And the magic line is just about there, which is our 7.8 volts. And we only ever drop down to about 7.7 when we're in full eclipse. We've had some interesting effects in this over the years. We've actually seen solar eclipses as we've gone behind. I think we've seen about 3 in its lifetime, just a tiny drop as it's gone into into eclipse. We also track the where we are at any point. We've got a Keplerian elements bit of software running in the background. So whenever we capture a piece of real-time data, we actually capture where the satellite, what the subsat point of the satellite was. Our friend Colin in Australia has been collecting data for more years than I care to remember. And every 2 weeks or so, he gives us the spin rate. You can see it's averaging about 3.6, 3.7 there. We've had it down to 2 seconds spin rate. Trying to get telemetry from it at that spin rate is something of a challenge. We still get it, and trying to command it at that spin rate is also a challenge as well. But we've succeeded. Now this is an interesting slide. This is how the spin rates changed over time, and we would love to know why this changes. It's gone from, you've got 9 seconds there down to 2 seconds, which is our worst case. Is it cyclical? Is it related to something to do with solar radiation? One of the things we've talked about within the team is, because we've got electrical currents flowing through the satellite, are they actually reacting with the magnetic field? And are we seeing some oscillation because of that? But it's long-term oscillation, and that just feels like it's a typical thing that a PhD student might like to look at. We've actually offered the data to students at University of Surrey to actually run some AI against it, see if they can analyze it. We're still waiting, is all I will say. I said that amateur radio operators are competitive. This is the ranking for all the satellites in the family, and I've just highlighted FUNcube itself. Where are we at? 1.62 million for HB9 MFL, and I think Mike's up there somewhere as well. G4BIP is one of our main contributors in the UK at the moment, and Brian's coming up the list slowly. I'm down there somewhere. The trouble is, because I test the warehouse, some of my numbers get somewhat skewed, so I never claim anything for it. But you can see that that number there, we've had maximum with uploads we've had have been about 2,500 users. Some of them they've only contributed, just for play. Let's contribute 5 packets. But the big players are up there. And Colin is there somewhere, our provider of our spin rate data. We're still doing fitter messages. We still give the opportunities for students and other organisations to upload fitter messages. We've got some advertising, of course, and a bit more advertising. We even try a bit of French as well. If anybody wants to upload request for a fitter message, please email operations@funcube.org.uk, and that will end up in my email box or some of the other operators. Moving on. David's mentioned FUNcube Lite with the sort of space south. We are thinking about, and we're more than thinking about, the next generation of FUNcube. I did a presentation 2 years ago, and I called it FUNcube Next, and it was going to be a 3U CubeSat. We've reduced our scope a little bit, and it's going to become a 2U CubeSat. I mentioned icy space and naive 1 and JY1SAT. They were not quite licensed, but we were given the opportunity to have parts in kind. They built the devices for the two organisations that that licensed our devices. So we were offered the opportunity to acquire components and the opportunity for icy space to assemble anything we actually came up with. We are in negotiations with the moment in terms of what we can acquire for free and what we have to buy. And on this little desk here, there are two devices which has just been put in my hand: the engineering EPS and the magnetorquer. So I've already opened this box once today, but I'm not going to go any more than opening this cardboard box. And I'm not going to open this because I haven't got any earth straps on me. But this is the EPS and it's the magnetorquer. So we've actually been delivered this today. So we're very, very proud. We're very, very happy. We're very, very pleased that Icy Space have actually honoured that part of the deal. What we have to do, because that doesn't cover everything, of course. We have to purchase some equipment, this is part of the purchase. But we also have been honoured in that they will be providing flight hardware for us as well. But as time's gone by, of course, that original negotiation was at a certain price. Things have gone up, so we may have to actually make up the difference, shall we say. I won't go all through this because this is all on the website, etc. But in principle, we've gone from, this was some of the original specifications. We've gone from 3U to 2U. We've gone from 3 transponders to 2 transponders. Camera, yes, maybe. On X-band, maybe. But it will, some of the things we're actually talking about, we're still talking about to our software engineers, is fly your own code as well. Actually, for the ability to upload data. One of our friends in the audience is also talking about possibly an SDR experiment on board, and we're also talking about high bandwidth downlink from the satellite. But it will be the same principle that FUNcube 1 and all our other satellites have been. It will be for STEM outreach. You know, the standard FUNcube that we had, that we still have, I should say, the FUNcube software and the data warehouse, it's going to still roll into this system. As part of this, we would like it to be a UK registered spacecraft. FUNcube 1 became a Dutch, and thank you to AMSAT-UK for helping us with this. FUNcube 1 is actually a Dutch satellite, not a British satellite. We have to apply for a CAA orbital license. The CAA are now responsible for orbital flight now. And if we go abroad, we have to apply for other licenses as well. If we go for a non-British launch, if we go for something like SpaceX or other organizations, we've got to apply for a different license as well. One of the things we have to do with the CAA is they triage us basically in terms of is it worth you applying for that license. So they do something called the red, amber, green test, and basically it's, you know, what's your worthiness? Do you have any flight heritage? Who are the people involved in the project? Who are the people backing the project? And that's basically what the red, amber, green comes from. We put our application in, I think, probably about 4 months ago, maybe a bit more now, and we got an orange. So we couldn't get a red, so we couldn't get a green because we couldn't specify who the launch provider was. But as far as the CAA were concerned, we can go ahead with a full application. That's my job as ONSEC in AMSAT-UK, representing the FUNcube team as well. We also have to apply to Ofcom to file for operations in space in terms of the frequencies we're going to use. That's another task for me as well. But we know a lot about that already, because some of our friends in the audience are responsible for the ITU filings for amateur radio satellites. But even though we know that process, there is an overlying process that we've actually got to apply to Ofcom for frequency filing for space. As you can imagine, we have to also apply for insurance. If we smack into something, another orbital asset, and there's going to be some money to be paid. So we're talking this week. I'm starting to talk to insurance brokers. I think I've got about 5 lined up at the moment. I've had some indications from the CAA, basically what their expectations are for insurance, but because we are not something that weighs 22 tons in orbit. We're something about a kilogram. But we already know that we coming to close proximity to other assets up there. We get spherical conjunctions, so basically, the probability of where your orbit is and what that conjunction of those two spheres is in approaching another satellite. In the past, probably 6 months, Graham's got the numbers in terms of how many conjunctions we've had. So we see conjunction come up, and it's maybe a kilometre. I think our worst case has been 200 meters. But then we see the other body has moved. So we believe it's probably a SpaceX spacecraft, and they've got thrust. We haven't. So the CAA, obviously, risk mitigation and debris mitigation, we need to take insurance out. I've gone slightly out of step here. We want to put a camera on board FUNcube Plus. Still under debate at the moment. As David said, with other spacecraft we've uploaded stored images. So our software engineers are basically looking at what's the best way to get data down from us. Our friends at SSTL have done some work with Raspberry Pis to get data down. So we're talking to them. Probably a lot of you know Chris Bridges. Chris Bridges is involved with a lot of our projects. And thanks to David Bowman, etc., there's a lot of work going on in parallel between FUNcube Lite and this particular project. So there's a lot of crossover between the two designs. David talked earlier about his radiation sensor. We're going to fly that on FUNcube Plus. If I say FUNcube next, excuse me. FUNcube Plus is going to fly David's gamma ray detector. It's been tested on the bench. I'm sorry, David, if I've stolen one of your slides. Tested basically with a laboratory set of emitters, and that's going to work extremely well for us. Again, as David said in his previous presentation, we have a set of telemetry blocks that we send down in terms of the real-time data, whole orbit data, FITA messages. We may change those to actually allow for the transmission of this data and the images as well, because we know we've proven that we could do that with JY1 sat. This is going back to what David was talking about, FUNcube Live on Jovian 1. The FUNcube team have been extremely busy for all these projects. And I'm one of the team, and I think there's 7 of us. we meet every Sunday evening to discuss what's going on. It becomes a technical discussion by the end of it. And there are discussions going on during this weekend regarding both projects. We try to get together fairly regularly, as often as we can, basically face to face to thrash things out. It always gets more intense the closer we get to the actual, to the design and towards launch. I'll go back a step to FUNcube 1, which we called KISSAT, Keep It Simple Stupid SAT was our first name for it. And I think the whole gestation of FUNcube 1 was probably about 4 years before we actually got to a launch. But one thing I will say to anybody who's actually considering a CubeSat is test it to death. ISIS are always give us the honor to say yours was the best tested CubeSat we've ever seen. That's 10 years ago since launch, and things have obviously got better. But we are really proud. We are really proud of the of how she's still working. I think that's it. I've finished early.
Well, thank you very much, Dave. I think quick round of applause for Dave, and then I think we've got some time for some questions.
Dave, you were saying about 2 transponders, so what are you talking in terms of?
Is David in the room anywhere? Okay. We'll be doing the normal linear transponder, but it's likely we're going to be using UHF and VHF. We're also talking about L-band as well. So yeah.
So you're talking VU?
Yeah. So there'll be probably a matrix of some kind on board, but that's to be decided. We've got to, as I said, we've got to go through the IARU evaluation process. So we've got to apply. We've got to write the whole diatribe and then submit that. We're not at that stage at the moment.
Next question. Anybody? Anybody from the stream? I guess it might be an early tea.
It might be an early tea, right? I'm now going to put my other hat on, my ONSEC hat.
Okay.
To say that people have been asking me this afternoon, what time's dinner? And I'll repeat this as often as people bump into me outside as well. Dinner is at 7:30 in the hotel. The hotel have asked us to gather at about 6:45 in the bar to move through to the restaurant at about 7:15. I believe that places have been allocated on the tables, but I'm sure you're more likely to move around. There'll be no raffle. And there'll be no auction tonight, so it's purely a social gathering. That's it. Thanks, Ian.
Okay. In that case, folks, I think we can head for an early tea back here at 4 o'clock, I believe.